Okay, so participants, after a lot of theory, now it has come time for action in our software. So I am not sure, but I think that all of you are aware of this R Studio. Can some participants confirm if they are aware of R Studio? You had basic sessions on R, but I'm not sure in which software you had on basic R or you had it on R Studio, but it doesn't matter much. The functionality is same and the underlying program is same. It is R or R Studio. So what I have taken here is that I will be sharing with sir and organizing team members the data set that I'm going to use now. So obviously you will have the recording of this session. So you have the liberty of watching it later on side by side, and it will get uploaded and you will watch it, and then you can do it, watch it and do it. You can pause, you can rewind. This is also advantage that is there in online and recorded sessions. So up you can do in practice. So don't worry, don't panic. And the data sets will reach you shortly, and when you see it in the morning of 9th, it will have already reached you. So no problem, you will have the data sets. I've just given data sets from my domain because there are a lot of participants from commerce business domain also, but you can use any data set, it doesn't matter. You only need to use variables which are of appropriate scales of measurement. So where you have to use categorical variable, you need to use categorical variable. Where you need to use numeric variable, you need to use numeric variable. And you also need to keep in mind that the variables that you have provided make some research sense, make some sense for your research and for your analysis. So you have already, I saw in the course structure of this program, you have already done descriptive analysis using R. So I will not go into the descriptive. I will continue, but I will share this whole code, and I'm sure you are aware of the way codes are developed and work. In R, you have covered basics. So I will directly come to the syllabus and the topic which I have been assigned, which is parametric and non-parametric tests hands-on using R. That is our primary goal for today. So basically, what we will be doing is that we will be, first of all, opening a data. So if you have the R Studio, since I have not got any confirmation, I'm assuming you have R Studio, because in R, otherwise it is slightly difficult, and R Studio is also free. But in R it's slightly difficult because you have to write a long code for opening data also. But R Studio is much more user friendly in that sense, at least for the basic things can be done right from the menu. So you have to go to file and you have to go to open file. And in open file, these are the data sets that I will be sharing with you. So in the open file, for example, I click on this marketing and operations data, and soon the marketing operations data will open. So just a second, I think, just a second. Meanwhile, if there is anything, any participant who wants to do it simultaneously, or they are writing, or they want, because it's a live session, we will have doubt session also. But if anyone who is doing simultaneously, you can keep writing your doubts in the chat, we can take it up. Because that's why we insisted for live sessions for our part, because it will give us advantage. The program is self-paced, but it will give you an additional chance apart from the doubt session to do it simultaneously. Yeah, Arpan is co-host. Okay.
Arpan, you want to ask something?
Yeah, I was just getting some data sets. Yeah, so basically, let me also briefly explain what is the data set. so that you are aware what we are working on, because the variables will come like x2, x3. So you can get an idea. I've taken very general variables which everyone can understand. It's not a big deal. I'm sharing with you an SPSS window in which the data is there. So the data is about corporate customers of a firm. This is a real world data of HPAT Industries. So HPAT Industries is a company which is into paper manufacturing, paper products, and it is located in USA, and it sells to a lot of corporate clients, lot of corporate customers who buy from HPAT in bulk. We are retail customers. We are individuals who buy for our limited use, but it sells to corporate customers. So what did HPAT do is that HPAT conducted a survey on their various marketing and operations parameters, just more like a feedback kind of thing. And they collected data from 200 of their corporate customers. And that data is presented and captured here. And the variables are like that. So one variable is customer type. So customer type has been classified like this: one if they are less than 1 year, two if they are 1 to 5 years, three if they are over 5 years. Then the industry type, magazine and newspaper industry type of the customer, to which industry they belong. Then similarly, firm size, whether the firm size is small or large. This is based on number of employees. So if it is less than 500, it is small. If it is more than 500, it is large. And where the customer is located, so in USA, North America, or outside North America. And then the distribution system. What distribution system do the customers have, indirectly through broker or directly to customer? And these are the parameters of marketing and operational aspects on which they have taken ratings from these customer firms. So how is the product quality of the paper? How is the e-commerce services, technical support, complaint resolution? Then towards the end, you will see these things: order and billing process, price flexibility, delivery speed, satisfaction, how likely they are to recommend HPAT to other customers, how likely they are themselves to purchase again, and do they consider strategic alliance, and what is the purchase level? So purchase level is that out of the total requirement of these companies, which are the clients of HPAT, what percentage of their total requirement they wish to purchase from HPAT, or they are purchasing from HPAT currently. So it can go from 0%, as you can see, to 100%. I'm just showing you in SPSS to help you understand that how the codings and the values are taken, so that you know this. So this is one data set, one major data set that we will be working on, and I will be introducing any other data set that comes through our analysis at different points. So first of all, I will have to open this data set. So file, open file, and I can look at this marketing and operations data. I am not able to open. I have to go to import data set here. Sorry. Open file will open it in SPSS or Excel. You will have to go for import dataset. Import dataset, you will see a lot of options. Text is actually CSV. Many times you find that there are data files which are labeled as CSV. CSV are comma separated values file. So CSV files have to be imported as text base. This is very, very important. Please note, most of the primary and secondary data that you download are downloaded as CSV file, comma separated values file. So CSV file is provided so that you have a less file size, and the data values are compressed. But when you are importing it, you will have to use from text base. If you are importing a CSV file, don't use Excel for a CSV file. Excel can open a CSV file, but for importing in RStudio, you should be using text base. So file, import data set from Excel, suppose, and I will have to browse. I will have to browse, and I will have to take the location, and you will get the preview also. You will get the preview here. right? It all looks fine. This must be ticked first row as names. Otherwise, you will have problem because our studio will not read the first variables in the first row. Our studio will not read the first row as variables. Okay, and then and this is the R command. If you know a little about R commands, so this is the R command. First, you will have to recall this package, read Excel, but that is automatically done in R Studio once you go through this route. So those who are doing in they are not using R Studio. So they will not have this option of file and import dataset. So they will have to provide this code. And if I click on import, so the dataset will open and it will be visible alongside your R script. Okay. I hope it is visible to all. This R screen.
Your screen is not shared.
It is not shared. Okay. Yeah. Please let me know. I tried sharing. Is it now visible?
Yes. Now it's visible. Yes, it's visible
Okay.
now.
Okay. Okay, sir. So I will show it again, students. How do you import? You go to File, Import Dataset. This text space is for CSV, and otherwise you go to Excel. From Excel, and from Excel you browse, and you can take up this marketing and operations data, and first row as name should be ticked, and then you click on import, and the data set will get imported. Okay. So once the data set is imported, we can easily run all these techniques and all this analysis. So I will first start with one sample test. So x6 is the variable pertaining to product quality. And in x6, we have got ratings from consumers. Like for other variables, we have got ratings from consumers on a scale of 0 to 10. So we want to suppose compare it against a benchmark. So benchmark value against which we have to compare, we will have to decide. We will have to decide the benchmark value. So suppose we decide that our benchmark value is 7. That is, we are thinking that we should at least get a 7 out of 10 rating, because this is company's internal parameter. They have to decide internally. This is not, software will not be providing you any guidance regarding this. This you will have to decide internally, that what is the performance criteria against which you want to compare the average value of a series. So in one sample test, we always compare the average value of a series against a benchmark. So how to do it? In R, we write, there is option for both 2 tail and 1 tail. So t.test is the general function, and then you brackets, you write the data. And please be careful. The data name that you take here should be the data name that is appearing on the side in the cross tab. You can in the other tab, you can see here, marketing operations data. It is written like that. You have to write it like that only. Don't go by the name by which you have saved the file. Write in the code the name that is appearing here in the next tab. That name is to be taken. And then dollar, the name of the variable. So x6, comma, mu is equal to 7. Mu is representative of population mean. So for using this sample data, we want to test. So what is the null hypothesis? We want to test that the average population value, or the mu, is equal to 7. For which variable? x6, which is product quality, and the rating is out of 10, 0 to 10. So we want to check that the average value of x6, which is product quality, is 7 in the whole population. So you will write like this, and then you will run this, and you will get the results. See, the results have come in the bottom half bottom part. This is which is the console part. So you can see that when we ran it, the null hypothesis was that the true mean or the population mean, which is mu, is equal to 7. And the alternate was that it is not equal to 7. So you can again, for hypothesis testing, there are different approaches: confidence interval approach and the p-value approach. But nowadays it's the p-value approach that is very, very common. So we go with p-value approach, and the probability p-value is the probability in favor of null hypothesis. So if you have again attended the first session that we had day before yesterday, yesterday, and for live participants day before yesterday, if you have attended the first session, you will know. If you're not understanding what is p-value, go to the first session of my series of sessions, in which I introduce the inferential statistics. So p-value is the probability in favor of null hypothesis, and our usual benchmark is 5%. If the p-value is less than 5%, we will reject the null hypothesis. So p-value here is 2.2 e minus 16. So basically it is 0.14 0.15 zeros, 0. Decimal, and after decimal there are 15 zeros. What does this mean? There are 15 zeros, and then there is 2 at the 16th place, and there is another 2. So basically, whenever you see this number e, so it tells you how many places after the decimal the value before e is going to come. So on which place after decimal the value before e is going to come. So 2.2 e minus 16 actually is a shortcut for writing a very small number. What is that number? 0.15 times 0 after decimal, and on the 16th place it will be 2, on the 17th place another 2. So it is a very, very small value. In fact, whenever you see e minus 3, minus 4, minus 5 and more, you understand that the probability value is very, very small. So the null hypothesis is rejected because we don't have enough evidence in favor of null hypothesis, and we gain support for alternate hypothesis, as I had explained in the first session of inferential statistics. So there is we have what is called a significant result because null hypothesis is rejected, and it means that the true population mean of this x6 variable is not equal to 7. So if it is not equal to 7, it will be either more than 7 or less than 7. That you can easily see. So sample estimates, you can see mean of x, it is provided here 7.894. So the true value of this is not equal to 7, and it is more than 7 actually. So it is significantly more than 7 because it is 7.894. And if I do the analysis again with 8, then you will get, I just ran this line of code. I just changed it. There's this is mu equal to 7, and the next line is just mu equal to 8. Don't worry, I will share the data set. I will share the code with you. So mu is equal to 8. So when I ran this, obviously 7.894 is very close to 8. So the null hypothesis, you can see from p-value, is not rejected. Why it is not rejected? Because the p-value is 27.97%, which is much more than the usual benchmark of 5%. So the null hypothesis cannot be rejected. And it means that the true population mean is indeed equal to 8. At least we cannot reject that claim. We cannot say, again, diplomatically speaking, we cannot say whether it is equal to 8 or not, but at least we cannot reject it. I think, Gauri, you have something to ask. I am not able to hear you. You may write in the chat. Your audio is unclear. So the okay. So the true value is not equal to 8. That alternate, there is no support for that alternate because we cannot reject the null. We have support for alternate only when we can reject the null. So, and you can see the reason also. Earlier we were comparing from 7, so 7 was quite far off from 7.894, so the null was rejected strongly. But here we are comparing 7.894, which is actual mean, with 8, and there is not much difference. That is why you are not getting this difference in results. And if you have to do one tail test, then you have to just add one more thing in the code. So t.test is the function, marketing operations data is the file name. Again, you have to take the file name as it is appearing to you in the next tab in RStudio. $x6 is the variable, mu is equal to 7, and you have to add another argument. This is called an argument. So this argument was optional. That's why we could earlier run this without adding it. But here we can add it. And this argument says alternative argument. So alternative is, in alternative, you can write greater or less. So if you're looking to have an alternate hypothesis which says that the true mean is greater than 7, then you will write alternative is equal to greater, like this, exactly like this, because this is a programming language. If you write even a word or a decimal, even a letter or decimal incorrectly, it will not run. You will get an error message. So you have to, it is, in fact, you can, I will be providing you this code. So you can keep this as a template, and whatever your data set is, you can just make modifications in this code only. So alternative is equal to greater means that you are doing an upper tail test. You want to test in the alternate that your average for x6 is more than 7. And the other can be that x6 is less than 7. Average for x6 is less than 7. So when we run this, you can see the results are almost instantly out. And the results say, you can see the alternate hypothesis first of all, that the true mean is greater than 7. And if we do for the other one, the true mean is less than 7. Here the p-value is 1. So again, we cannot make much interpretation out of this, because true p-value is coming out as 1. So it means that there is almost certainty that the null hypothesis cannot be rejected. You can also try this with 8. Let's try with 8. If we get any different results. So you can see true mean is greater than 8 and the p-value is 0.86. So you can say that the null hypothesis cannot be rejected. So the null is that it is equal to 8, and the alternate is true mean is greater than 8. But alternate we can use, or we can accept in a way, or we can gain support for alternate only when null is rejected. But in this case, null cannot be rejected. And null says that the null, the p-value is 0.86. So there is 86% probability in favor of null. So we cannot reject the null. And what does null say? That the true mean is equal to 8. So it is not different from 8. Similarly here, the null was true mean is equal to 7, but you cannot reject that. Okay, so in this way, it is very easy. It is nothing very complicated. You can use this code. So first of all, import your data set using the process I said, and then you can run one-tailed or two-tailed sample tests on this. Then we had talked about paired sample test, and for a paired sample, I had explained to you a lot yesterday also. In the doubt session and in the main session also, I had explained that you can take a lot of before and after situations. So for example, I have a data set which is called stock returns pre-post crisis. So there was a global financial crisis in 2008-9 basically, but it had origins earlier, but it manifested mainly in 2008 and prominently from 9. End of 8 and early 9 period. So with the collapse of Lehman Brothers and all. So in that, what I'm trying to compare is that, is there any difference between the stock returns of India before and after global financial crisis? And if I can take a moment to show you the data set, I will show you the data set. So I think my Excel file is visible. In this, what I have done is that I have taken a monthly stock return. So in 1 month, how much returns you get from the stock market, and that return is for two countries, India and USA. And for India, we have taken Sensex as the proxy of stock market, and for USA, we have taken S&P 500 as proxy for the stock market. So we have the pre-IND series, that is the return series before the manifestation of global financial crisis, returns on Sensex, which is the Indian benchmark. Monthly returns on Sensex before global financial crisis, 5 years before, 5 years, and monthly observations. So 5 into 12, 60 observations before the crisis. And I have taken the onset date of crisis as 1st September 2009, when the crisis was full blown. So then we have uh, the data for 5 years or 60 months of Sensex returns after the crisis. So before and after the crisis, we have this data. Okay, so post IND is India's Sensex stock returns, monthly Sensex stock returns post the onset of global financial crisis, 5 years, 60 observations, and pre-IND is India's monthly Sensex stock returns before the onset of global financial crisis. So basically, it is the pre-IND data is from September 2004 till August 2008, and the post data is for September 2009 to August 2014. And remember, since we are doing a pre and post comparison, so the number of observations must be equal. So we have to have 60 observations before and 60 observations after. Like I had explained in the doubt and the main sessions, that if you have 100 patients, so for the same 100 patients, both the pre and post data must be available regarding their health parameters. Okay, so I have explained the data set to you, and now let's go to R Studio. And in R Studio, you can do this. So the equation is, the program code is like this. It is not very difficult. See, it is called, again, we are starting with t.test. We had used t.test earlier also. Again, we are saying t.test. T.test, and this code has become slightly longer because of the long file name. But again, I will have to first open this file. So I will have to, before running this code, I will have to open this file. Otherwise, it will show an error message. So I will go to file. Again, this is an Excel file. So file, import data set from Excel. And I will browse to the location. And then I will click on import. I will click on import. And you will see the stock returns pre-post crisis file, which I showed you in Excel. You will see it opening here in R. Okay, so this file is here. Now I can run this command t.test. Again, stock returns pre-post crisis. I have given a fairly long name. You can keep a short name. This is the file name, dollar, which variable I want to pick from this data set, pre-IND, comma, stock returns pre-post crisis, which are variable I want to pick from this data set, post-IND. And in the end, because similar thing we had provided earlier also, but How do we know that we are running a paired, because this is a paired dependent or related samples test. So how do we know that we are running in the paired one? You have to add an argument at the end, that in this t.test function, you will have to add an argument at the end that paired is equal to true. Paired is equal to true. This you have to add, and you have to write true in caps lock. Remember, R and Python both are case sensitive programming languages. So true has to mean this capital TRUE. It cannot be small. So we write it like this, and we run it. So you can see the results have come almost again instantly, the paired t-test results. So you see, we have compared the data, stock returns pre-post crisis is the data set. In that we have compared pre-IND and post-IND series. So the null hypothesis, what will be the null hypothesis? Null hypothesis will be that there is no difference. There is no significant difference between the pre and post crisis stock returns. There is no significant difference between the pre and post crisis stock returns, and that null hypothesis cannot be rejected in this case. Again, why cannot be rejected? Because the p-value or the probability in favor of null hypothesis is 46%, more, slightly more than 46%. 0.46 is 46%. So the null hypothesis cannot be rejected. That means there is no significant difference in the pre and post crisis Indian stock market returns. And you can see the magnitude of the difference, that is mean of differences, was very, very small. So what we do basically is that we take the pre-IND series and we take the post-IND series, and we construct a difference series, which is pre minus post or post minus pre, doesn't matter much, but we create a difference series and we run basically a one sample test for that difference series. One sample test for difference series with mean is equal to 0. So that's why you can see here from the alternate that the true difference in mean is not equal to 0. And the null is that the true difference in means is equal to 0. So we create a difference series, and for that difference series, we test using one sample test that the average of that difference series should be equal to, or mean of that difference series should be equal to 0. So that is null, and it is not equal to 0 is the alternate. And you can see the value is very small, 0.009, so very close to 0. That's why the null hypothesis is not getting rejected. If this difference was very large, the p-value would be lesser, and maybe the null hypothesis could have been rejected. And again, this was the two-tailed, but if you add one more argument after paired is equal to true, like we did earlier, like this alternative is equal to greater or alternative is equal to less. If we add this argument at the end, then you will get what is the one-tailed test. So for if I run this, you can see you have got the results for one-tailed paired t-test. So you can see, you can check whether the one-tailed is run or not from the, you can check that one tail has been run or not from the alternative hypothesis that comes in the output. That is a very good thing in R Studio, that they provide the alternate hypothesis. So the alternate hypothesis is the true difference in mean is greater than 0. In two-tail, what was the alternate? True difference in mean is not equal to 0. But here we are specifically saying greater than 0, indicating the upper or the greater or the right tail test. But again, in this case, also the p-value is, this p-value is basically divided. Earlier it was 46% for two-tail, now it is 23%. But still 23% is also significantly higher than 5%. So our null hypothesis cannot be rejected. null hypothesis would still continue to say that the true difference in mean is equal to 0. So the null hypothesis remains same, whether you do two-tailed test or alternate test or the one-tailed test. It is just that if the null hypothesis gets rejected, what interpretation you will draw depends on the type of tail that you are testing. So if our null hypothesis got rejected in the previous case, suppose instead of 46%, it was 4%, and we reject the null hypothesis. So in this case, the conclusion that we will draw is that the difference in the pre and post global financial crisis stock returns is not equal to 0. That's the difference we will draw. And since the mean difference is positive, so you will say that the pre-crisis stock returns of Indian market was significantly more than post-crisis stock returns, because the mean, it is always first minus second. So it will be pre-IND minus post-IND, and that difference is positive. So you will say, that this is, the rationale, that it is, the difference is positive and it is significant if it was 0.04 instead of 46% or 0.46. So you would have said that the true difference in mean is not equal to 0 and the pre-IND return is significantly more than post-IND returns. But if in this case it was, say, again 4% p-value or 2%, then you would have arrived at a slightly different conclusion. You would have directly understood that the true difference in means is greater than 0. Again, we are doing pre minus post, so conclusion will be same. Because the fact is same. So you will arrive at the same fact in both ways, whether you do one tail or two tail test. In one tail, you will directly arrive at it. But we generally don't prefer one tail test because we don't know in advance. For example, you don't know in advance that whether pre returns will be more or post returns will be more. So you don't know that the pre minus post difference, it will be positive or it will be negative. So, that's the issue. Okay, so similarly, you can run the lower tail test, and similarly, you can run the Wilcoxon test. So Wilcoxon is the non-parametric version of this. So as I had explained to you in the PPT, that we have the non-parametric substitutes for these parametric tests. So Wilcoxon sign rank test is the non-parametric substitute for paired samples t-test, which is paired sample t-test is parametric and non-parametric version is Wilcoxon sign rank test. So in so the code to run the Wilcoxon test is wilcox.test. And again, we have the stock returns pre-post crisis, which is the file name $pre-IND, stock returns pre-post crisis $post-IND, and paired is equal to true. So if you run this, you will arrive at almost same conclusion. So the null hypothesis is again not rejected. So there is no significant difference in the two data sets. That is pre and post IND average stock returns. Though in non-parametric, we don't, compare average. We will say, you can say median instead of true location shift. You can also say median, because I had told you non-parametric tests compare median instead of mean, which is compared in parametric techniques. So you can say that the null hypothesis, which says that the median of difference is equal to 0, that null hypothesis cannot be rejected. So there is no significant difference between the pre and post crisis Indian stock market returns. And it is this conclusion from Wilcoxon sign rank test is same as the conclusion that we just arrived at using our parametric counterpart, which was independent samples t-test. Sorry, a paired samples t-test. So this was about this. Now let's come to what we call independent samples test. This was the paired or dependent or related samples test. Please, if you are not understanding these things, please go back to my yesterday's videos, including the doubt session video. I gave you a lot of examples to clarify what it means, whether the data set is paired, dependent, or related, and what it means that the data set is independent or unrelated. So for independent samples test, I am opening and I'm showing you another data set, which I call as Hrob data. So just give me a second. Meanwhile, if any live session participants have anything to ask, please feel free to write in the chat. And those who see it in the video, you can ask tomorrow if you're not here now. But those who are here, you can ask now also. So Hrob data. First, I will show you this Hrob data, and then I will do the independent sample status, because you must understand what the data is. Otherwise, as I have repeatedly said, myself being an analyst person, but I always say that analysis doesn't make sense. So this data is about the survey taken from employees. So employees were asked about a lot of things, including their experience with the company, this HBAT only. So HBAT also took a survey of its own employees. So gender of employee, employee type, whether part-time or full-time, geographic location of employee outside USA or USA, because HBAT itself is operating outside USA and USA. So similarly, they are asking for employee location, age, experience in years. Then we have some very important variables like job performance of employee. It is measured on a scale of 1 to 5. 1 is very low performance, 5 is very high performance. Then organizational commitment, environmental perception, staying intention, all of them has been measured using these scale items. I will share this with you. So those who are interested in, I said earlier in one of the doubt sessions that these are latent constructs, staying intention, organizational commitment. So these latent constructs cannot be directly measured through any instrument, and they are asked through multiple statements. For example, SI is staying intention, and we have asked it from our employees in 4 different ways. So SI1 is I am not actively searching for another job. SI2 is I seldom look at job listings on Monster or in Indian Gunstead, Naukri or something. Or you can simply ask on job portals. SI3 is I have no interest in searching for a job in the next year. SI4 is how likely is that you will be working at HBAT 1 year from today. And the coding is like that, very unlikely and or very likely. So basically we are asking the same thing again and again because we need to validate. We need to validate from we need to validate the response of the participants for any one particular statement with their responses for other statements. If their responses for all these 4 statements on staying intention are consistent, then we will go ahead with analysis. But that is for those researchers who want to do behavioral and questionnaire based research and they are developing scale. So you should do it like that. So I think you have understood the variables that are there. So let me take you back to the R studio. And for carrying out independent samples test, we again use the same generic t.test function. So it is called t.test, and the data set is Hrob data. T.test, then we have Hrob data, which is the data set. But again, let us first open it. So file, import data set from Excel. I don't know if it is an Excel file. Oh, sorry, it is an SPSS file. So it is, since it is an SPSS file, I will have to go to file, import data set from SPSS. I will select file, import data set from SPSS. And here I will choose the Hrob data. And then you can see I'm getting the preview Preview looks fine. And how have I calculated these end variables, OC, EP, SI? What I have done is that I have either taken a summated scale, or most likely, I think, I have taken an average. So there were 4 statements of staying intention. All of them were asked on a 5-point scale. So I have taken the average of those 4 statements. So employee would have responded 4, 5, 4, 4, 4 on those 4 statements. So 1, 5, and 4, 4. So for the second employee, you can see here, the average value is 4.25. So I have taken the average of responses for each employee on the 4 statements related to staying intention. Okay. And then I import this data set in SPSS and as R Studio. And as I have been telling you, you can see it appears in the next tab. And you can see that it is HROB data is visible to you here. Okay. And again, the name which is appearing here, we will use, because I had written it like HR space and space OB space data, but you don't write that in the code. You write what is appearing here, HR underscore OB underscore data, because this is what R Studio is reading it like that. So you need to provide that. So here I have written t.test HR underscore OB underscore data. Then again, dollar, which variable? I suppose I want to compare job performance across gender. I want to check today is International Women's Day. When I am recording this session, when we are having live session. So let's see if the performance of HBAT's employees differs between the genders, or is it same? So let's see. It's a matter of empirical investigation. So HROB data $JP. JP is job performance. And this diddle operator you have to provide in between. And then, so first, always remember, in the independent samples test, you have to first provide a numeric variable or the scale variable. And after the tiddle, you have to provide the categorical variable across which you want to compare. So we want to compare job performance across categories of gender. So we will first provide the numeric variable job performance, and thereafter we will provide the gender. So we run this and we get this results almost again instantly. You can see the results say that what is the p-value? The p-value is that the average job performance is same for males and females. The p-value says, the null hypothesis says that the average job performance is same, or that there is no difference in job performance between male and female groups. There's no difference in job performance between male and female groups. And the alternative will be that the difference is not equal to 0. So the null will say that the difference between average job performance of male and females, the difference between average job performance of males and females is equal to 0. That will be null. And the alternate will be that the difference between average job performance of males and females is not equal to 0. But here you can see that the p-value is 77%, 0.77 is 77%, much higher than the benchmark of 5%. So the null hypothesis cannot be rejected. So the null hypothesis, which says that there is no difference in average job performance of males and females, that null hypothesis we cannot reject. And you can see the reason also. In the sample estimates, you can see that the average job performance of females is 4.36 and the average job performance of males is 4.33. So the average job performance of females is slightly higher than males. So congratulations to them on International Women's Day, but the difference is not significant. This is a very minor difference, 0.03. So it is not statistically significant. Then suppose we want to compare JS. JS is job satisfaction. So we want to compare JS across the type of employee. So employees can be part-time or full-time, as we saw in the data set. So we want to compare JS across employee type. So if we run this, then again, what will be the null hypothesis? That the average job satisfaction of full-time and part-time employees is same. That is, the average, there is no difference between average job satisfaction of full-time and part-time employees, or the difference between job satisfaction of full-time and part-time employees is equal to 0. The difference between job satisfaction of full-time and part-time employees is equals to 0. That null hypothesis cannot be rejected. You can see the p-value here. P-value is 66%, 66.2%. So the null hypothesis cannot be rejected. And again, you can see the reason that the average job satisfaction is 13.92 for full-time employees, and for part-time employees, it is 13.71. So both the values are very close. And the non-parametric substitute of independent samples t-test is Mann-Whitney U-test. So it is run using the Wilcox.test. It is run using the Wilcox.test function of R. So you can run this and you will get similar results. Again, you can see the p-value is 84%. So there is no significant difference in the median job performance of males and female. And if you run this Wilcox test on job satisfaction, then you will see that the p-value is 70.81. That is, there is no difference in median job satisfaction of full-time and part-time employees. There is no difference, same result as above. And in this, we had 0.8414. So there was no difference in median job performance of males and females. And here, no difference in median job satisfaction of full-time and part-time. So same results as the parametric test. And the last thing for today is the one-way ANOVA. One-way ANOVA and its post hoc and the non-parametric substitute. So we would have covered all the parametric and non-parametric techniques. Correlation also, we have parametric and non-parametric, but correlation, parametric and non-parametric we will do in the next session, because we have exclusive session for correlation and regression analysis using R. So in what we are comparing X19 and X1. So X1 is basically the customer type. So we have divided the customers. I will, again, you can look in the data set, but I'm just telling you, X19 is satisfaction. X19 is satisfaction of the customer measured on a scale of 0 to 10. No, sorry, measured on a scale of 0 to 100. X19 is customer satisfaction from HBAT's products measured on a scale of 0 to 100, X19. And X1 is a categorical variable, because I told you if we have to compare across more than 2 categories, then we use one-way ANOVA. One-way ANOVA can be used for 2 categories also, but if we have to compare across more than 2 categories, we can use only one-way ANOVA. We cannot use independent samples t-test, because t-test can be used only for 2 categories. X1 is a categorical variable, which is the type of customer, 3 types of customer: less than 1 year, 1 to 5 years, and more than 5 years. So all the customers are divided into 3 groups based on how long they have been associated with us: less than 1 year, 1 to 5 year, and more than 5 years. So X19 is customer satisfaction on the scale of 0 to 100, and X1 is a categorical variable of customer type. So we write it like this: res.aov is for results of ANOVA. ANOVA or AOV is for analysis of variance. So res.aov. So don't write anything else. Write it like this. Okay, sorry. No, this is not the, this is something which we are giving the name. So you can write anything here. Res, AOV, you can change, but you cannot change this. This you cannot change. AOV written here, you cannot change, because this is the function of R that you cannot change. This is like t.test. So what we are doing is that we are creating a variable, or we are creating a variable or name using a name and providing it a name res.aov. And in this, we want to store the results of ANOVA. And then we will ask the R Studio to provide the summary of ANOVA results. So first you compute and store it in a variable, and then you ask R Studio to display it using the summary function. So the command is AOV X19. Again, the numeric variable you have to write first. So customer satisfaction X19 first, then title, then X1 customer type, comma, and data is equal to marketing operations data. So if you run it like this, and then you ask for summary of the results, you will get this. And then you need to do post hoc analysis, because see, if you see here, you see here, this p-value is 2e minus 16. So you can easily understand that there are at least 14 zeros post the decimal, 14, 15 zeros. So the null hypothesis is getting rejected. What would be the null hypothesis in this case? Again, no difference. No difference of what? So no difference in average level of customer satisfaction across the customer type. So irrespective of what is the customer type, there will be no difference in average level of satisfaction. So that null hypothesis gets strongly rejected. So once that null hypothesis gets rejected, we want to find exactly which pair. Why do we do post hoc analysis in ANOVA? We want to find exact pair between which there is that difference, because we have three groups: less than 1 year, 1 to 5 years, and more than 5 years. So the difference can be between any two of these: less than 1 year, 1 to 3 years, less than 1 year, more than 5 years, 1 to 3 years, and more than 5 years, 1 to 5 years and more than 5 years, 1 to 5 years and less than 1 year, less than 1 year and more than 5 years. Across all the three groups, we can have difference. So to find out exactly amongst which two groups we have the difference, we go on to do post hoc analysis after the results are significant. So we use Tucky HST as the method of running post hoc analysis. And we run this. I think there's a problem because it is not recognizing X1 as categorical data. Okay. It is saying no factors. It is not recognizing X1 as categorical data. We will have to check. So, Saurav sir, I'm just taking 2-3 minutes more so that this topic is over, if it is fine with you.
No, it's okay, sir. It's okay.
Okay, sir. Okay, yeah. So I have found the problem participant. See, in X1, we have written it like 1, 2, 3. So SPSS is considering, R Studio is considering it as a number. It is not considering it as a categorical variable. And it is not generating this Tucky, because for Tucky, it should be written like this. You can see X2, the way it is written: magazine, newspaper, magazine, newspaper. X3 written like large, small, large, small. It should be written like this. For us to get the result, I will just try to import the other one file. If it works. Okay, so basically you can run this. Okay, let me show you. Let's just change it to say X2 and then run it. So you will get the results. You can see you will get the results. So all you need to do to run this and get results is that you convert this 1, 2, 3 to categories, like less than 1 year, 1 to 5 years, and over 5 years. You can do that in Excel and then run this command. This command will be with you. So once you do that and then run it in, change that in Excel and then run it in RStudio, it will work. So just change it to from 1 to 3 to 1 is less than 1 years, 2 is 1 to 5 years, and 3 is more than 5 years. And the non-parametric version is Kruskal-Wallis test. And again, the p-value is less than this. So you can see that the null hypothesis is getting strongly rejected. And I had earlier discussed crosstabs and chi-square also. So there are two variables, x2 and x3. x2 is a type of industry to which the customer belongs, magazine and newspaper, and x3 is the size of the firm. So if I have to generate a crosstabs table, as I had shown you in the tutorial and the session earlier, so we use this table command to generate. So table, the data set, dollars first variable, comma, data set, dollars second variable. And then you have to write the name of the table again so that it is displayed. For example, look at this. Then I write my table. So you are asking this. So you get this table. This is the crosstab table. So there are 55 firms which are large and magazine industry, 45 firms small and magazine industry, 47 large and newspaper, and 53 small and newspaper. And then you run this chi-square test. So what is the function? CHISQ chi-square dot test. And in the bracket, you write the name which you have provided. This my table is not a command. Command is table, and command is chi-square dot test. This my table is the name I have provided. You can provide table 1, table 2, anything. But keep the consistency. If you have written my table here, you need to write my table only in the next two commands. So if I run this, you will get the chi-square test. And the p-value is 32%. 32%, which is more than 5%. What is the null hypothesis of chi-square test? We are basically doing chi-square test of independence here. So the null hypothesis is that the two variables x2 and x3 are independent of each other. Independent, so the two categorical variables, I had explained to you that in chi-square test of independence, we use two categorical variables. So x2 and x3, the two categorical variables are independent of each other. So that null hypothesis cannot be rejected. And you can see from the data pattern also, the distribution is uniform. The distribution of large, small firms or industry type does not depend on each other. So this null hypothesis of no relation or independence is cannot be rejected. There is just one query before I stop. HPAT is the name of a company from whose data we are using. That's what it is, Gaurinder. Okay, over to you, sir.
So thank you very much.